Hi to everyone. So this is the engineering section and some mining. So we will cover oil sand, but today example will be take maybe iron or metallic ore. So it's ore reserve estimation, and what we do in this we estimate the reserves what we have in mine, open pit mine, and on the basis of which then we calculate the slope angle of the pit, the cut-off grade, then the basis of which we do the mining. So it's a kind of calculation, and after that, then it's a designing stage, designing open pit mining. So what we assume that the drill hole data is available, geology, hydrological study, and statistical and geotechnical studies are available. Property, boundary, plant layout, power, water, etc., reclamation, financial, mineral and waste terms. Is all data is available. So on the basis of which then we do the ore reserve estimation. So what we do, let's say if we have 40 holes in our area of influence, so we do grade. We make a grade. Grade mean that if we drill hole, so the area of the influence, let's say this is the hole, so the whole influence of the area will be 100 feet or 200 feet. So it will, we assume that it will cover 200 feet or 300 feet of area of influence, whatever we got in this hole. So that's called grade. And then the whole area, let's say of 40 or 50 holes in the area, spacing, center spacing of 100 feet, 150 or 200 feet. So then the area, let's say, is 30,000 square feet. So the whole 40 or 50 holes, we do polygon around each hole for the optimization of the hole and calculating the grade. And then we calculate the tonnage, the whole tonnage, waste tonnage, and our ore tonnage, and the grade of the block around the hole. And also we calculate hydrological study from the hole, geotechnical study, geostatistical analysis, and geology detection. So for that, what we need and what we have to do is a tonnage factor. So the equation for this tonnage factor is tons divided by the specific gravity into multiplied by 62.4 pound per feet cube. This is the water specific gravity. So it's the weight of the, let's say it's a oil sand or it's a metallic ore. So the weight of that unit in the water, we call it. That's the specific gravity. So what we got from that tonnage factor, let's say is 2,000 pound per ton. 4 is a specific gravity, and this is the water specific. So we got 8 feet cube per ton. You guys are with me? Let's say we assume that we got 8 feet cube of iron ore per ton. 8 feet cube per ton. So this is in the calculation. Next we will use it. The second one, let's say the whole area is 3,000 feet square. So 3,000 feet square divided by this tonnage factor, 8 feet cube per ton. So we got 3,750 tons per feet vertical. Per feet we got this tonnage. Let's say in 1 feet we have this ton of the iron ore, and let's say assume oil sand. So this is when we convert this tons to the pounds to the another tons, TONNE, so it's got 3402 tons per meter cube. Assume, let's say that the cut-off grade, what is cut-off grade? Cut-off grade is the production cost divided by the value into recovery. Let's say that the production cost is $30.6 per ton, and when we are selling in kg, whatever unit, in a small unit of the ore, kg or something, so the unit price is $40, and this is the recovery. 0.85% is our recovery. So what we got? We got 0.9 pounds per ton. So this is the cut-off grade, and then the conversion factor. So this is we got the grade. This is called cut-off grade. What we got? The whole mining is based on this, and this is the ore reserve estimation. So after that, when we calculate this tons and cut-off grade, so then we do the pit slope angle. Yeah, from where we starts mining. In the case of I'll say little overburden, we can start from the beginning, but in some ore, we have to remove the overburden. So the continuation of ore reserve estimation is this is, let's say, this is like an example of the hole. Let's say this is a hole, and up to 100 feet we have the overburden, and up to after that 400 feet we have the oil seam. So the total length is 500 feet. So the slope angle is directly proportional to the height. The pits, the whole pit mining, let's say 1,000 feet square or 2,000 feet square, 5,000 feet square of mine, and the economic limit, the slope angle is directly proportional to the height. Let's say it's 500 feet. So this will be directly proportional to the elevation. So difference in elevation to economic bottom of the pit. So this is the difference in elevation, actually the slope, which provide the final slope angle. So this is usually 1.5 into 1, 1.1 and 1. So height to elevation ratio give you the slope angle. And for the bench, then we have to calculate the bench. And in the polygon area, this one, polygon area into depth, when you calculate the area around each hole in polygon and into the depth, so it's give you the volume and then multiply by the unit weight, tons per feet cube or tonnage. So then this will give you the whole tonnage of the waste and the ore. In this case, our ore, our economic mineral is this one, and this is the waste. So that's, you can calculate the ore, and on the basis of which then we go, once we establish the slope, pit slope, and then the bench slope, then we go in our next stage to for the mining. So another parameter like capital cost and operating cost and risk analysis and all these things, and after that we select the equipment based on our daily production, daily, weekly, yearly production. Then we calculate the life of the mine. After that we select machinery like trucks, shovels, loaders and all and other accessories, and then we start production and buy the equipment, and that will be our planning. Thank you guys, and have a nice